All right, section 1.2, we're solving multi-step equations. It's day 2 of this. Our goals are to be able to solve a multi-step equation with one unknown variable on each side of the equation, but also we're going to solve equations that have one or infinite solutions. So real quickly, let's review. The first step, use inverse operations to isolate the variable I've highlighted, because ultimately that's our goal. We're going to use inverse operations to get the variable, whatever the variable is, by itself. And then below here are the steps that we will follow, typically in this order, but we've already seen some examples where sometimes we have to switch up the order depending on how the problem is set up. And then the special cases we talked about, these are going to start showing up in these problems today. So if you're solving an equation and all of the variables completely cancel out, they just don't exist anymore, and you're left with a true statement. So for example, all the x's may cancel out and you're left with something like 7 equals 7. That is an example of infinite solutions. So for instance, if you had something as simple as, well, what if x plus 1 is equal to x plus 1? Well, the left side and the right side of this equation are exactly the same. And if we solved this one, if we subtracted x from both sides in this problem, the x's would cancel and we'd be left with positive 1 equals positive 1, which of course that is true. So that is an example of infinite solutions, when the variables cancel out and you're left with a true statement. Likewise, similar manner, you get no solution when you're solving it and all of the variables cancel out and you're left with a false statement. So for instance, if you get x plus 2 equals x plus 3, and if we subtract x from both sides here, we would end up with positive 2 equals positive 3, which makes no sense. That means that equation has no solution. Most of the time, it's not going to be obvious if it's infinite or no solution until the very end of the problem. So for instance, these examples we're about to work out, that could happen in either one of those examples, but you can't really tell at first glance looking at these. You've got to actually solve and see if everything cancels out and you end up with a true statement or a false statement. So example 1, solve the equation 4g plus 12 plus g equals 3g minus 8. So let's follow these steps. We do not have to worry about the first step because there are no parentheses. The next step says combine like terms on each side independently. So if we look at this expression on the right side, you have 3g minus 8. Those aren't like terms. But on the left-hand side, this expression independently, if we combine those terms, we would end up with 5g plus 12. So that is the second bullet point. We can check that off. We've done that. All right, the next bullet point says move variables to one side using inverse operations. So our variables are 5g and 3g in this problem. So we would need to move these to the same side. I'm going to move the smaller of the g's to the left side. So the inverse operation of positive 3g is subtracting 3g from both sides. So when we do this, we end up getting 2g plus 12 equals, let me do my vertical line right down the middle. These 3g's cancel and give us 0, and then we'll drop down the negative 8. I didn't mean completely erase it there, but I did. And now our like terms, we're going to subtract 12 from both sides. And we're going to be left with 2g equals negative 20. And then finally divide both sides by 2. We're left with g equals negative 10. So this one had a clear solution. Example number 2. So let's go through our steps. The first step, distribute to eliminate parentheses. We obviously have parentheses, so we're going to distribute the negative 3, and that gives us negative 6f minus 12 equals 2f plus 12. So that is the first step. Second step, combine like terms on each side independently. We don't have like terms on the left side or on the right side, so we can skip this step. The next step says move variables to one side using inverse operations. So we have a negative 6 and a positive 2. Again, I always like to move the smaller of the variables to the other side. You don't necessarily have to do it that way, but the negative 6 is smaller than the positive 2f. So the inverse operation of a negative 6f is a positive 6f. I'm going to add that to both sides. So we're left with negative 12 on the left side. On the right side, we have 8f plus 12. So we've accomplished that step. We've moved variables to one side. And then finally, move constants to the other side. And remember, we want to move them to the other side away from the variable. So this time, this positive 12, it's got to go because we want the f isolated. So we're going to subtract 12 from both sides. 12 minus 12 is 0. Negative 12 minus 12 is negative 24. And then finally, multiply or divide away the coefficient. So this is 8 multiplied by f. So we're going to undo this multiplication by dividing both sides by 8. And we're left with 1f equals negative 3 as our answer. So number 3's got a lot going on. But first off, we're just going to follow the steps. We want to eliminate the parentheses first. So I'm going to rewrite everything in the problem just below. 4m plus 7 minus 3m. And when I distribute the 2, I get 2m plus 6 minus m plus 1. So the only thing that changed in that first step was distributing that 2. The next step is we're going to add like terms independently on each side. So this left side, I have a positive 4m. And be careful here, a negative 3m. So positive 4 and negative 3, 4 minus 3 gives us 1m. And then the plus 7, I'm just going to bring down since it doesn't have a like term. Do my vertical line down the middle. And then let's look at the right side independently. The right side has some like terms. It has a positive 2m and a negative 1m. So 2m minus 1m is just 1m. And then positive 6 and positive 1. Add those together, we get positive 7. Probably see where we're going with an answer in this problem. But the next step is we get the variables together. There's not a smaller variable. They're exactly the same. So when I subtract m from both sides, these m's cancel and these m's cancel. And then we're left with 7 equals 7. That is a true statement. And all that means is true's not the answer. The answer is infinite solutions. Meaning no matter what we substitute back in for x in the original problem, it would make this equation true. So infinite solutions is our answer because this last statement is true. All right, and then our final problem, we've got parentheses, so let's distribute the 4. We get 12p plus 20. On the other side, we're going to distribute the 3, and that's 30 plus 12p. There are no like terms on the left side or right side independently. So our next step is we're going to get the variables together that are on opposite sides. Well, both of them are positive 12. So it doesn't matter which one we decide to move, because if we subtract 12p from both sides, those cancel and those cancel. Again, I don't know why it's all deleting, but that's fine, because they all cancel out, and we end up with positive 20 equals positive 30. And that does not make sense. That's false, which means there is no solution. There's no value we could substitute in for p in this problem that makes this equation true. And again, that's because the variables canceled out and we were left with a false statement. That's how we know.